Hey everybody, Mr. B here. In this video, we'll be going over the practice problems in the chapter 2.1 notes on properties of matter. So here we go. Number 1, classify the following properties as extensive or intensive. All right, so just to remind ourselves, extensive properties are typically going to be things that are dependent on the amount of matter that we have in a sample. So it depends on amount of matter. And intensive properties are things that depend on the type of matter. So it depends on type of matter. All right, so let's go through each one of these and try to determine if it's dependent on the amount of matter or type of matter. So color, what color something looks like. Does that matter how much of it you have, right? If you have a lot of it, is it going to be green? If you have only a little bit of it, is it going to be red? Probably not. It's going to be green or red or whatever color it is, just based on what it's made out of. So that's going to be intensive. That's dependent on the type of matter that we have. Volume, so how much space it takes up, that is going to be dependent on the amount of matter you have, right? If you have a lot of it, it's going to take up a lot of volume. If you have a little bit, not so much. So that is an extensive property. Mass, how much matter there is in the actual object itself, that depends on the amount of matter that you have, not the type of matter. So that is also going to be an extensive property. And then boiling point, or the temperature that it turns from liquid to gas and it boils, that's going to be dependent on the type of matter, right? So like, think for example, water. Water boils at specifically 100 degrees Celsius. It doesn't matter how much you have. If you have like a giant bucket of water or like a little cup of water, it's still going to boil at the same temperature. So that is an intensive property. All right. Number 2, true or false, lemonade would be an example of a substance. So remind ourselves, again, substances are things that have a uniform composition, meaning that they look the same. If you look at it, it looks the same everywhere. And they also have a definite composition, meaning that no matter where you find it in the world or the universe, it's always made of the same material the same way. So lemonade, although certainly lemonade, tastes very similar depending on where you get it from, lemonade is not made the same way everywhere. And it doesn't look the same either, right? If it's fresh squeezed lemonade or if it's lemonade that comes from like the frozen little cans you get at the grocery store, like the from whatever it is, the condensed whatever things. Versus like canned lemonade, right? If you get it just, you open up a can, all kinds of different kinds of lemonades. Some have pulp in there, some don't, like the amount of sugar, some are sugar free. So no, lemonade is definitely not a substance. That is false. Okay, not a substance because it changes depending on where you go. Number 3, true or false, table sugar, aka sucrose, that's the chemical name, would be an example of a substance. So a little bit of a hint here. If a material has a chemical name like sucrose or something, pretty much tells you already that it's going to be a substance. Because if it has a chemical name, that means it has a chemical formula, which means it has a formula that like specifically tells you what it's made out of. Okay, so table sugar, no matter where you go in the world, it's always going to be made of the exact same material. It's going to look the same. It's going to taste the same. It's a substance. Number 4, true or false, tap water would be an example of a substance. So this one is another tricky one, right? Tap water would be like water that comes out of your sink. You might fill a glass up and drink it. Not going to be a substance. Tap water from your house, you might have city tap water, or you might have well water, right? But, tap water at your house might be different from tap water at the school, which might be different from tap water at your friend's house. I'm sure you've gone to some place where you've taken a drink out of a drinking fountain or maybe out of, tap water from the sink, and it tastes like it's kind of like minerally, right? Kind of like metallic tasting. Probably because there's more, iron in it or more minerals in it, and it's different from the water you have at your house, right? So the composition itself is different, and no, this one is not going to be a substance, even though it might seem like it will be. It's not. All right. Number 5, classify whether steam would be a solid, liquid, gas, or vapor. So solid, liquid, gas, most of you guys obviously probably know how to determine that. A vapor, just to remind you, is something that's a liquid at room temperature, but it's in its gaseous form. So steam, of course, which is water that is turned into a gas. Water is a liquid at room temperature. And then steam, of course, being in a gaseous form, this would be considered a vapor, because a vapor, again, is any material that is a gas, but at room temperature would be a liquid. Okay, so that's a vapor. You could classify it as a gas, too. That'd be fine. Number 6, classify whether a hockey puck would be solid, liquid, gas, or vapor. Obviously, this one's pretty obvious. A hockey puck would be a solid, right? Okay. And number 7, state whether melting butter would be a physical change or not. So remember that physical changes are when you change what something looks like, but it's still made out of the same stuff. So if we took butter and we melted it from solid to liquid, is it still butter? Yeah. It's still butter, still looks the same, still tastes the same, still smells the same. It's just now in a liquid form, right? So physical changes happen when you change what something looks like, but it's made out of the same stuff. So this is a physical change. Number 8, state whether burning gasoline would be a physical change or not. Okay, so this one's a little bit tricky. So, if you take gasoline and you burn it, obviously gasoline is flammable, so it's going to go up in flames. Let's just imagine you have like a little cup of gasoline, okay? You light it on fire, goes up in flames. Is there gasoline left over? No, right? It's going to be gone. Okay. Have you taken that gasoline and just turned it into a gas, right? Like if you heat up a cup of water, it's going to boil and it will all disappear, and you've now just turned it into essentially water vapor. It's a gas that's floating around in the air. Is the gasoline that you burned a gas floating around in the air? You might think, oh, maybe. I don't know. Maybe. Okay. If it was, could you condense it back to a liquid? So water, when you boil it and it turns into steam and it's in the air, or it's water vapor, if you cool it down, it will condense back to a liquid, right? So like this is what happens in the fall when it starts coming closer to winter time and the temperatures start to drop. All the water vapor in the air, the humidity, condenses in the morning. You get dew on the grass, right? Everything's wet. That's from the water. That's a gas in the air. But as the temperature drops overnight, it condenses from gas to liquid, and you get liquid droplets of water on the ground. So if you burn gasoline and it's a gas floating around in the air, can you cool it down and it will like rain liquid gasoline out of the air? No. Okay? Burning gasoline is not a physical change. When you burn gasoline, you're actually turning it into water vapor, carbon dioxide, and there's some energy that it gives off. Okay, this is what's known as a chemical change, which we haven't talked about yet. But the main thing to understand here is that if you burn gasoline, the gasoline's gone. Okay, it's not there anymore. You haven't just turned it from liquid to gas. It's gone. It doesn't exist anymore. It's completely different material. There's no gasoline left. So that is not going to be a physical change. You're changing it into something different. Okay, so not physical change. That was a little bit tricky because we haven't talked about chemical changes yet. But, if you think about it in your head, if you burn gasoline, it's not there anymore. It's gone. It doesn't exist. So, all right. So that was the last question for this section of notes. Hopefully it helped you. As always, if you have any questions, make sure you email me, reach out. We can chat about it. And, yeah. So, all right, guys. I will see you in the next video. Bye.